And welcome back, students. As we get into some programming techniques for exception handling, today we're going to discuss something known as the finally block. So before we kind of jump into that, let's just quickly discuss a quick pitfall regarding that of nested try-catch blocks. So you can try to place a try block in its finally catch box inside the larger try block or inside a larger catch block. Technically it will work, but it's something you kind of use on a rare occasion. It's almost always better to place the inner try blocks inside of a method definition and place an invocation method in one of the outer try or catch blocks. Or maybe just to eliminate one or more try blocks completely. The reason you do this is because it helps isolate it so you're not, for example, let's just say you need to debug your program. If it's isolated to a method, it's a lot easier to trace it back than if it's a nested try block, because you don't know if it's necessarily the inner try block or the outer try block causing the issue, because you could have, if you have an exception, let's say a general exception that gets thrown in either of them, is it the general exception being thrown in the inner or the outer try block? Yes, you could specify it, but this is just a real basic example to kind of help you understand why it's a little bit better to do it in methods. Plus, when you put it in methods, it's a lot cleaner too. You don't have all this try-catch just convoluting your code. All right. If you place a try block and its following catch blocks inside of a larger catch block, you're going to need different names for the catch block parameters in the inner and outer blocks. Kind of as I already mentioned, you can't, if you just have an exception, well, it's going to be confusing to know which one is the exception. Additionally, if they're all the same, Java's going to yell at you because it's going to want to know which exception are you talking about. So the reason for this is it's how Java handles nested blocks of any kind. Remember, try blocks and catch blocks are still blocks of code. Now, if you place a try block and its following catch blocks inside of a larger try block, and an exception is thrown in the inner try block, but not caught in the inner catch blocks, then the exception is thrown to the outer try block for processing, and might be caught in one of its catch blocks. So what that means is your inner code may not reach the corresponding inner code for the catch block. So you want to make sure that, if you do it with methods, this problem's not there. Otherwise, it's something that you may have to program and account for when you design your program. So again, another good methodology for why you should put the try-catch inside of methods rather than just try to put it all nested inside your program. All right, enough of that. Let's discuss the finally block. So the finally block contains code to be executed whether or not an exception is thrown in a try block. So when we look at this, we're going to get some quick example here. So the finally block, if it's used, is placed after a try block and its following catch blocks. Right? So it's kind of like the last thing you want this program to do. So the general syntax is something like it follows: try, catch with your first exception, catch multiple exceptions, and then you have your final, which is some code to be executed whether or not an exception has been thrown or has been caught. Now, suppose that the try-catch finally blocks are inside that of a method definition. After all, each set of try-catch finally blocks is in some kind of method, even if it is on the main method. Now, there are three possibilities when the code in try-catch finally blocks is run. The first is that the try block runs to the end and no exception is thrown. In this case, the finally block is executed after the try block. Or, next instance, an exception is thrown in the try block is caught in one of the catch blocks positioned after the try block. In this case, the finally block is executed after the catch blocks are executed. Or an exception is thrown in the try block and there's no matching catch block in the method to catch the exception. In this case, the method invocation ends and the exception object is thrown to the enclosing method. However, the finally block is executed before the method ends. Now note that you cannot account for this last case simply by placing the code after the catch blocks. Right? And that's kind of the key thing here is that what the finally does is kind of acts as like a must execute. Because if you don't, let's say you have an instance where your catch block doesn't catch and then it throws an exception. Well, what the finally does is it forces Java to still run that code first before the exception is thrown. So it's kind of like, hey, you're going to crash the program, but finally is going to kind of step in there to kind of say, wait, before you do that, why don't you go ahead and do this one more thing. So it's not exactly how it works, but it's a simple enough explanation to kind of give you the gist of what the finally block is doing. Kind of say, wait, I could just add code after the try catch block. Wouldn't that do the same thing? Not quite, because finally, in a way, like I said, kind of helps force Java to do that last bit of code. All right, and that's going to end the notes. You'll get some, there's actually a demo using finally in the self-test questions. So we will see you next time.